Alright, hey guys, welcome back for lesson 9.1 day 2. Have the board started, set up for us to get started. Our goals today include solving triangles and looking at a word problem. Alright, so first off, when you're asked to solve a right triangle, that means you need to find all the missing sides and angles. Alright, if the angles are not 30, 60, 90, or 45, 45, 90, you're going to need a calculator. Okay, make sure you check your calculator mode, radians versus degrees, and I'll show you that in a second. When you reset the memory of your calculator, it automatically resets to radians. And you're going to learn about radians in this chapter, and there are going to be times where we want our calculator to be in radian mode. But if we're doing right triangle trigonometry, we want to be in degree mode. Okay, so let me reset the calculator with you. Okay, so if you push second plus 712, the way I make you always reset it before taking a test or a quiz. All right, let me darken my screen real fast. Okay, so I just reset it. I'm going to hit mode. And when I hit mode, you guys can see, right, if I go down a little bit, that it's highlighted in radian. I want to go over to degree and push enter. All right, so that radian is no longer highlighted. And then I'm going to push second mode because that'll bring me back to my main screen. It lets me quit that previous screen. So now I'm in degree mode. All right, so the very first problem, we're asked to solve triangle ABC. Again, when you're asked to solve and reading the directions and knowing what that means is important, it means find all the missing pieces. You are given two pieces. You're given that angle A is 34 degrees. And you're given that side B is 13. All right, so I can label angle A 34 degrees, that was given. And then side B is 13. Well, how do I know which side is side B? I believe we did this in one of our other chapters as well. If this is angle B, the side across from it, this is side B. Here I have angle A, the side across from it, that's little a, side A. And angle C across from it is side C. Okay, so that's how you determine which sides are A, B, C. All right, so side B is given as 13. All right, so I have a right triangle. I know one of the angles. I can quickly find the missing measurement of the other angle by simply subtracting 34 and 90 from 180. All right, so the measurement of angle B, that's the first thing I'll figure out because that's the fastest. The measurement of angle B is going to equal 180 minus the 90 minus the 34, because I know the three angles of a triangle always have to add up to 180 degrees. And that'll give you a measure of 56 degrees. So the measurement of angle B is equal to 56 degrees. All right, so I can label that there. Now, the next thing I need to do is decide, can I use special right triangles? Can I use those side relationships that I explained in the last lesson for 30, 60, 90, 45, 45, 90? And you can't because this is not a 30, 60, 90, or 45, 45, 90. So we have to use trigonometry, okay? So what you're going to do is you're going to decide which acute angle you want to work with and then label the sides according to that. All right, so you can either use the 34 degree acute angle or the 56 degree acute angle. Since we were given the 34 degree angle, that's the one I'll focus on. All right, so if I'm focusing on this angle here, I'm going to label this my opposite side. That's across from it. The one across from my 90, that is always my hypotenuse side. And then this would be my adjacent side. Okay. So I'm trying to solve for the opposite, or I could solve for the hypotenuse. I'm going to have to do both, but let's start with the opposite. I'm trying to solve for opposite, and I know adjacent. So think about SOHCAHTOA for a minute. SOHCAHTOA. If you know opposite, and you're trying to find adjacent, opposite, adjacent, I'm going to use a tan function. Tan of the angle, tan of theta, tan of 34, is equal to opposite over adjacent. So I'm going to do that work over here. So again, it's tan theta equals opposite over adjacent. Well, theta is the angle. Opposite, I don't know. I'll leave it as A. Adjacent is 13. So it's tan of 34 equals A over 13. And if this seems like review, it is. You guys did this in geometry last year. All right. In order to get A by itself, I'm going to multiply both sides by 13. All right. So A is going to equal 13 times tan 34. Make sure you don't multiply the 13 and the 34 together. Okay, tan of 34 is a value. That's what you want to multiply by 13. So I'm going to type it into my calculator just as it is on the board or on your paper. 13 times tan 34, and you get approximately 8.7, whatever it is. And we're going to round to 2 decimal places. So I'm going to say A is approximately 8.77. A is approximately 8.77. Okay, so approximately 8.77. Now the last side I need to solve for is B. Or sorry, C. We know B. C. Alright, so I'm trying to solve for hypotenuse. I know adjacent. So which one of these deals with hypotenuse and adjacent? That would be cosine. Alright, so I'm going to set up cosine of 34 equals adjacent over hypotenuse, 13 over C. Okay. The first thing you're going to want to do is get C out of the denominator so you can multiply both sides by C. Or if you want to look at this as a proportion, put this over 1 and then do cross product. Sometimes students like to look at it that way more. So cross products, you're going to multiply the 1 and the 13 together. That'll give you 13. And set that equal to C times cosine 34. So C times cosine 34. Still not done. I have to get C completely by itself. So I'm going to divide both sides by cosine 34. So divide by cosine 34. Cosine 34. All right, so C is going to equal 13 divided by cosine 34. And I put that in my calculator. Get my fraction up there, 13 over cosine 34. And you should get 15.68, I think, if I'm reading it right. 68, yes. So 13 point, that is not right, is it? 13 divided by cosine 34. Oh, yeah, it is. I don't know what I'm looking at on my paper. It is right. All right, so C is approximately 15.68. Okay, there we go. All right, so a few comments before we move on. First off, notice when I went to solve for side C, a side here, I did not use 8.77 in my calculations. If you can avoid using an approximated rounded value in a calculation, you always want to try to avoid it, okay? So in order to get the best, most accurate answer, never use approximated values. If you have no choice, depending on the problem, then obviously use your approximated value. But my point is, I could have said, all right, I'm going to solve for the hypotenuse by using the opposite side. And I could have said sine of 34 equals 8.77 over C. But I'm going to be using an approximated value to find another value, so my answer is not going to be as accurate. All right? Any other notes that I need to give you guys? I think that is it. Yep, just be careful about that. Oh, also, instead of using 34 as my acute angle, I could have done 56. I could have looked at angle 56. But then this would be your opposite side, and that would be your adjacent side. So just make note of that as well. Okay? Let me erase, and we'll get set up to do the one-word problem for today. Okay. So I'm just going to read this to you and then we'll draw a diagram, but you can go to the notes to have it in front of you if you need to. So a parasailer is attached to a boat with a rope 80 feet long. The angle of elevation from the boat to the parasailer is 31 degrees. Estimate the parasailer's height above the boat. All right, so this is also a review from last year in geometry when you guys learned about angle of elevation depression with your trig unit. All right, so we'll sketch a picture, and I am by no means an artist, so I do stick figures. Okay, here is my person who is parasailing, and here is the boat, and here is the rope from the person to the boat. Okay. So it says, again, a parasailer is attached to a boat with a rope 80 feet long. So I can label my rope, that's 80 feet. All right. It says the angle of elevation from the boat to the parasailer. So a quick review of angle of elevation. Pretend you're on the boat right here. Okay. If you're on the boat and you look straight out, that would be your horizontal view, your horizontal line of view, okay? And then if your eyes look up at that parasailer, that angle that's created, that's your angle of elevation. So that angle of elevation was given as 31 degrees, all right? The question is saying how high up is the parasailer above the boat, okay? So the height of the parasailer, remember height is always measured with a perpendicular segment. So imagine if you were to drag the boat underneath the parasailer, that would be the height. So this segment right here represents the height. Now we are doing right triangle trigonometry. So with these word problems, the goal would be to sketch a diagram that includes a right triangle. All right. And if we're trying to solve for the person or the parasailer's height, that would be this side here. Okay. So once you have your diagram set up, I'm going to write SOHCAHTOA so I can figure out which trig ratio to use. And I'm also going to label the sides of my triangle opposite, adjacent, hypotenuse, because that'll help me figure out which trig ratio to use as well. Here is my acute angle. This is my opposite side because it's across from the acute angle. My hypotenuse is always across from the right angle. And then here's my adjacent. So I'm trying to find the opposite, and I know the hypotenuse. Which one of these deals with opposite and hypotenuse? That's how I determine I need to write a sine function. So it's sine of the angle, sine theta, equals opposite over hypotenuse. So it's sine of 31 equals x over 80. All right, to get x by itself, you're going to multiply both sides by 80. So multiply this side by 80, multiply that side by 80. All right, and in your calculator, you're going to do 80 times sine of 31, and you'll get 41.2 feet approximately. So x is approximately 41.2 feet. Okay. And that is it. All right, guys, so that is it for day 2 of lesson 9.1. Jump over to the online textbook, get that homework done, and I'll see you back here for 9.2.